Hi guys, I'm Raul from Simplilearn and welcome to this video on CPM or the critical path method. So first, let's find out what exactly is CPM. Now the critical path method is an algorithm that's used in project management to schedule project activities. Now one of the biggest advantages of CPM is that it gives you a model. You create a model through which you can determine the different tasks that are required to complete the project, the dependencies between these tasks, and the duration required to complete a particular activity. The critical path is the longest stretch of activities and a measure of them from start to finish. Now, to understand the critical path method, there are certain things that you need to know. So let's have a look at a completed critical path method diagram or a network diagram. So this is somewhat what a final version should look like. So here you can see these circles with numbers in them. We'll also need ABC. So let's talk about what this is. So the two major components in a diagram, a network diagram, are events and activities. So as you can see here, a circle, this circle with a number in between it, represents a particular event. This is present at the start and end of an activity. So here, A, B, C, D, E, F represent activities. And each activity, like I mentioned, has a start and an end node. So for activity A, this node, node number 1, is called the tail node. And event 2 or node 2 is known as the head node. Likewise, each of these activities have a different tail and head node. There are also other things that you need to know before you can start drawing your own network diagram. The network that you create should have a unique starting node. Here you can see there's only one starting node, one unique starting node, which is node number 1. There's no multiple nodes starting off the network. Then the network should have a unique completion node, which is node number 6 here. There's only a single node which completes the entire network. No activity should be represented by more than one arc in the network, which means that this arrow that you see, this represents an arc. There's only one activity responding to an arc. This means that no two activities can have the same starting node as well as ending node. And finally, there's this thing known as a dummy activity, which is represented by dotted lines between two nodes. Say, for example, 4 and 3. So this dummy activity represents a relationship between node 4 and node 3. But at the same time, there's no duration or there's no activity, and if there is, that activity will have 0 value, unlike every other activity that you see in the network. So this is the basics of the critical path method. Let's understand this better with an example. Our objective here is to determine the critical path of this data represented here. Now here you can see, let's have a look at each of these different columns. We have activity, immediate predecessor, and duration. Now the duration, let's assume, is in months. So let's write that down. Right. So now let's have a look at activity and immediate predecessor, because that's what's currently important. So here we have activity A, who does not have any immediate predecessor. Similarly, activities B and C don't have immediate predecessors as well. So first, let's draw activity A. So since it does not have an immediate predecessor, it will have a node of its own connecting to it. So first, let's draw node number 1. This is node number 2. Let's connect them both. Here we write down the activity connecting them and the duration, which is 3. Likewise, let's have a look at activity B. It also does not have an immediate predecessor. Let's see which other activities have B as its immediate predecessor. We have activity D as well as activity G. So let's draw that too. It's node 3, B, 4 months duration. Next up, we have activity C. C also does not have an immediate predecessor, but it also acts as an immediate predecessor for activities H and I. Let's draw a node for activity C. Number 4. Let's write down the duration, which is 6. Now, let's have a look at activity D. Now, D is preceded by activity B. However, a combination of C and D act as immediate predecessors for H and I, which means that C and D will have a common point of origin, which is right here. So, let's connect node 3 and node 4. This represents the activity D, which is 3 months. Now let's have a look at activity E, which is preceded by activity A. So now let's have a look at activity E. The immediate predecessor for activity E is A, so we can directly draw that, and as you can see here, there's no combination of different activities here, so we can draw E directly. So let's draw the node. There we go. Let's connect the node. 5. E, which is 9. Right then, now let's go to F. F is preceded by A. But at the same time, let's have a look at where F is used. F is also an immediate predecessor of K, which is a combination of F, G, H. So let's come back to F in a bit. Let's go to G. So as of now, we've completed A, B, C, D, and E. Let's skip F for now and go to G. G is preceded by B. At the same time, it is used as a combination of F, G, H, which means G can come here. Which is 4. So G is complete. Now there's only F left. Now H. H is a combination of both C, D, which means its origin point comes from here. So whose origin point is the node 4? Both H and I originate from the node 4. So as we can notice here, F, G, and H both act as immediate predecessors for K and L, which means at some point they all need to unite, which is exactly here at node number 6. So let's combine H and G. Which has a duration of 5. So let's now go back to F. Now F we can combine to node number 6 since we know that F, G, and H come together at some point. So let's combine F to this node. There you go. F with the duration of 1. Now we're done with node number 6, or we're also done with H. Now for activity I. Now activity I is preceded by C, D. I also acts as predecessor for M, so it's an independent activity. So let's add that separately here. Preceding 4. Let's connect that. Node 7 with I, which is 4. Right. I is complete. Let's go to J. J is preceded by E right here. and is only used as combination for n in the end. So at some point, j and k need to combine. As you can see here, L, M, and N don't act as immediate predecessors, which means they represent final nodes, or they connect to the final node, as you found out earlier, which is one of the rules when you're creating a network for yourself. So let's draw K. K and L are both preceded by F, G, and H. But we also know that for N, J and K connect with each other, which means we can draw J here. So finish J. And since J and K together connect towards N, we can also assume that K moves from here, from node 6 to 8. That's right, K, which has a duration of 6. Now for L. Now L is preceded by FGH, but it is not an immediate predecessor for any other item, which means that it connects to the final node right here. That would be node 9. L, which duration is 3. So now we have M and N left. M is preceded by I, so let's draw that. And N is preceded by J and K. So this is N is 9, and M is 6. So now the network is complete. And now let's find out how to create the critical path. So to understand the critical path, or to determine the critical path, we need two paths, the earliest start times and the latest completion times, which are both represented by ES and LC. Now the earliest start time refers to the earliest starting times of each node. Likewise for latest completion time. So each node has its own earliest start time and latest completion time. They are represented in a box. So we'll create boxes for each of these nodes. There you go. And each of these boxes need to be divided. So in these boxes, the lower half represents the earliest start time and the upper half represents the latest completion time. So first off, we'll find out the earliest start time. So the process of finding the earliest start time is referred to as forward pass. Now the earliest start time can be determined with the formula. So the formula is earliest start time of the ending node is equal to the max earliest starting time of the starting node plus the distance between them. So let's see what we mean here. So one thing you need to know is that the earliest starting time of node 1 is always 0. So let's write that down in a different color. It's always 0. So let's have a look at the earliest start time for node number 2. So the earliest start time when it comes to the previous node, which is node number 1, is 0 plus the distance, which is 3, which means the earliest start time for node number 2 is 3. Let's write that down. Let's have a look at node number 3. Here the earliest start time for node number 3. 0 is the earliest start time of the previous node plus 4, which is the distance, which equals 4. Let's put that down here. So that's 4. So now let's have a look at node number 4. So here, however, there's a difference. Since there are two nodes coming towards it, which is from 1 to 4 and from 3 to 4, we'll need to determine the maximum from both of these coming nodes. So for the earliest starting time for node number 4, it's either 0 plus 6, which is C here, 6, or 4 plus 3, which is B plus D, 7. So here, considering that we are taking the maximum of both, we'll have to choose 7, which we'll write down here. I hope you guys understood how we did that, which is basically we took the maximum of both the values that are coming towards the node number 4. Likewise, we'll have a look at some of the other ones that are coming soon. So let's have a look. So here we have a similar issue for node number 6. So for node number 6, we have 3 points coming towards the node. There's F, G, and H. So which of the following is the least? Let's find out. So here 3 plus 1 is 4. So for ES5, earliest start time for node number 6 would be, it's either 3 plus 1, 4, or 4 plus 4, 8, or 7 plus 5, 12. So since we're taking the maximum, let's take number 12 and write that down. So the earliest start time for the node 6 is 12. Likewise, let's have a look at node number 5. Since there are no different nodes connected to it, we just have to add the number from the previous starting node, which is 3, and the distance, which is 9. We combine to form 12. Let's write that down. Now for node number 8. So when you have a look at node number 8, you can see that there are 2 nodes connected to it. There's one from 5 and one from 6. So let's have a look which one we'll select. So it's either 12 plus 3, which is 15, or 12 plus 6, which is 18. So let's go ahead with number 18. So the earliest starting time for this node is 18. So let's have a look at node number 7. So since there are no other different nodes connected to it, we can directly go with 7, which is the earliest starting time of the previous node, plus the distance, which is 4. This is totaling to 11. And finally, we have node number 9. So 9 has 3 different points connecting to it, which is 18 plus 9, 12 plus 3, and 11 plus 6, which you can see here, 18 plus 9, 12 plus 3, and 11 plus 6. As you can see, the winner is the maximum, which is from node 8, which is 27. And like that, we've completed the forward pass, which we've determined the earliest starting time of each of these nodes. Now, let's have a look at the latest completion time. For this, we'll start from node number 9 and work our way back to node number 1. So for latest completion time of the last node is always equal to the earliest starting time, which means that here latest completion time of this node is 27. Now the formula for latest completion time is latest completion time of the previous node is equal to the minimum latest completion time of the head node minus the distance between them. So let's see what we're talking about. Let's go to node number 8. So basically, when there are multiple connections shooting out of a particular node, we need to decide a number of different options. In this case, node 8 is directly connected to node 9. Basically, we can calculate the latest completion time for node 8 by using the formula directly, which is 27 minus 9, which will get 18. So let's put that here. So latest completion time for node 8 is 18. Let's have a look at number 7. Here again, we have a direct connection between node 7 and node 9. So therefore, we can find the latest completion time for node 7 by directly applying it with the formula, which is 27 minus 6, which is 21. So let's write that down. Let's go to node number 6. Here, there are 2 points extending out of node 6, which means we'll need to choose from 2. Here we have 27 minus 3, which is 24, or 18 minus 6, which is 12. Now we need to choose the minimum of the both. So let's go with 12. Let's write that down. So the latest completion time for node 6 is 12. Now let's go to node number 5. So for node number 5, the latest completion time will be, since we're directly connected to node number 8, 18 minus 3, which is 15. Let's write that down. Let's go to node number 4, which has 2 points connecting out of it, H and I, to nodes 6 and 7. So let's choose among the two. So for node number 4, it'll be either 12 minus 5, which is 7, or 21 minus 4, which is 17. So which one should we choose? The minimum, which means the connection towards node 6 is the correct answer, which is 7. 12 minus 5, 7. Now for node number 3. So node number 3 has 2 points shooting out of it. So we need to choose from either the connection to node 6 or node 4. So for node 6, it's 12 minus 4, which is 8, or it's from node number 4, which is 7 minus 3, which is 4. Hence, we'll take the connection from node number 4. So let's take the latest completion time of node number 3 as 4. Now for node number 2. So since there are two connections coming out of it, we'll need to choose between the connection to node 5 or the connection to node 6. So for node 6, we can directly conclude that choosing the node number 6 would be a bad idea, because the final answer would be 12 minus 1, which is 11. Or it could be 15 minus 9, which is 6. So clearly, the answer is 6, since we've taken the minimum of the both. And finally, we've come to node number 1. So here, the final answer, it's either A, B, or C, which is node 2, 3, or 4. So for node 2, we have 6 minus 3, which is 3. For node 3, we have 4 minus 4, which is 0. And for node 4, we have 7 minus 6, which is 1. Clearly, we have a winner, which is node number 3. So let's write the latest completion time. It's 0. And there we go, the backward pass is now complete. So how do we now find the critical path? The critical path can be determined with the help of satisfying certain conditions. Let's have a look at what they are. So to determine the critical path, we need to satisfy 3 conditions. They are: the earliest starting time and the latest completion time need to be equal. Similarly, for the head node, the earliest starting time and the latest completion time also have to be same. And finally, the earliest start time of the second node, which is the head node, minus the earliest starting time of the tail node, should be equal to the latest completion time of the head node minus the latest completion time of the tail node. They should also be equal to the distance between the two nodes. So let's have a look at which of the following satisfy these conditions. As you can see clearly, node number 1, node number 3, node number 4, node number 6, node number 8, and node number 9. So all of these nodes I mentioned satisfy these two criteria. Let's have a look at if it satisfies the third criteria. Here we have 4 minus 0, which is 4, 4 minus 0, which is 4. We have the correct answer. 7 minus 4, which is 3. Similarly, 7 minus 4, which is 3. 12 minus 7, which is 5. Likewise, all of them connect, which means we have just found out our critical path. The critical path for this question is B, D, H, K, and N. The critical path is B, B, H, N. And thanks to the help of the critical path, we can also determine the maximum amount of time to complete our project, which we can determine by combining the durations of each of the members of the critical path, which is 4 plus 3 plus 5 plus 6 plus 9, which is equal to 27. which means 27 months. And there you go. We've just solved a question with the critical path method. And with that, we've reached the end of this video. I hope you guys found this informative and helpful. Don't forget to click on the like button and subscribe for more. Thank you for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.